All right, let's talk about the ghosts in the machine, specifically the invisible security risks lurking inside all those AI assistants we're starting to rely on. Some really groundbreaking research has just come out, and it turns up a pretty surprising fact. When it comes to AI security, our biggest and smartest models, well, they aren't always the safest. Let's dive in. I mean, really think about it for a second. We're handing over more and more of our daily tasks to these incredibly powerful tools. But are we actually sure they're safe? That they can't be manipulated? This isn't some far-off hypothetical question anymore. We're talking about the tools you're probably using right now. Take, for example, your AI coding assistant. That thing has access to your entire codebase, right? Your company's most secret stuff, its proprietary information. A single vulnerability there could be, well, pretty disastrous. Or how about your AI travel planner? It's out there scraping websites, booking flights, and handling all your personal details. It's plugged directly into the open internet, which, as we all know, is just filled with potential traps. And the stakes get way, way higher with something like an AI financial advisor. You know, it's crunching sensitive market data, looking at your personal financial documents, all to give you advice. A security flaw in that system could have some very real and very expensive consequences. So here's the crucial point. We can't just take our old security playbook and apply it to these new AI agents. It just doesn't work. The problem is fundamentally different. It's a whole different beast, and that's exactly what makes it so tough to solve. And this right here really breaks it down perfectly. See, with traditional software, we hunt for bugs. We find them and we patch them, kind of like fixing a leaky pipe. But with AI, the vulnerability isn't really a bug. It's actually a feature. The very same ability that lets an AI follow your instructions is what lets it follow an attacker's instructions. It literally can't tell the difference between data and a command, and you can't just patch that. So, to even begin to tackle this, the researchers realized they needed a completely new tool. They needed a way to see these invisible attacks as they were happening. So they invented something they call a threat snapshot. You can think of it like a brand new type of security camera, one that's designed to catch a totally new kind of crime. What a threat snapshot does is it basically freezes a single moment in time. It captures everything the AI knows in that one instant. The user's request, any documents it's reading, its system instructions, and it combines all that with a crystal clear description of what an attacker is trying to make it do. It's a perfect photo of the crime scene, right as it's happening. And building one of these snapshots is a pretty straightforward two-step process. First, you pinpoint the exact state, that precise moment the agent is vulnerable, and you capture all the context it has. Then, step 2, you just define the threat itself. What's the attacker's goal, and how are they trying to pull it off? Okay, so now they have this incredibly powerful new tool. What do they do with it? Well, they built the ultimate stress test for AI agents. They basically set up this massive, gamified challenge to see just how vulnerable these systems really are when real people try to break them. And the scale of this thing is just, wow. They crowdsourced almost 200,000 unique attacks from actual human players. These are people trying their absolute best to trick and break these AI agents. So this isn't just theoretical stuff. It's a huge data set of real-world attacks. And they didn't just test one or two AIs. They threw all those attacks at 31 of the most popular large language models out there. You know, the backbones of pretty much every modern AI agent. This makes it one of the most comprehensive security tests ever. All of this incredible work led to the creation of something they call the B-cubed, or the Backbone Breaker Benchmark. And what that is a standardized test that anyone can now use to measure the security of any LLM, treating security as a top-tier feature, right up there with performance or capability. So, what did they actually find? Well, the results from this benchmark turned up some genuinely surprising truths that really go against a lot of the common assumptions we have about how these AI models are supposed to work. So here's the first big question they decided to tackle. We all kind of think that bigger, more powerful models must be better at everything, right? That should include security. But is that actually true? Nope. The data is clear. Bigger does not mean safer. And this just illustrates the point perfectly. Whether the models were tiny, small, or large, their vulnerability scores were all over the place, but generally pretty similar. Just making a model bigger doesn't automatically make it more secure. In fact, sometimes the researchers found the bigger models were even a little bit worse. But here's the kicker, the thing that does make a huge difference, and honestly, it's completely counterintuitive. It turns out that enabling a model's reasoning capabilities, prompting it to kind of think step by step before it answers, that actually makes it more secure. You can see there's a huge drop in vulnerability when reasoning is turned on. It seems like a more thoughtful AI is also a safer AI. Who knew? And so here are the final rankings. The top performers with reasoning enabled were models like Grok and Claude Opus. But down at the bottom, it's a real mix. You see some older models, sure, but also some newer ones. It just goes to show you that security is its own unique thing for each model. It's not just about how new it is or who made it. Okay, so let's bring this all home. What's the big takeaway here? Why does any of this research matter to you, whether you're building AI, selling it, or just using it every day? This quote from the paper just hits the nail on the head. We have to completely change the way we think about AI security. We're not hunting for bugs we can fix anymore. We're trying to manage inherent features of the technology itself. And that requires a whole new game plan. This really does change the game for everyone. For developers, it means you can't just pick the biggest, most powerful model off the shelf. You have to consider which one is the most secure. For the providers, they now have benchmarks like B-Cube to actually prove their models are safe. And for all of us as users, it's a huge reminder that these amazing tools come with new kinds of risks that we're only just now starting to get a handle on. And that really leads us to the final, huge question. This technology is not slowing down. As these AI agents get smarter, more autonomous, and more woven into the fabric of our lives, the challenge of keeping them safe is only going to get bigger. This research gives us the tools to start measuring the problem, but actually solving it, that's going to be the great challenge for all of us in the years to come.